Okay, let's go ahead and finish off this note sheet. So again, we were talking about formulas and properties of the summation problems. Again, it's important that you know these properties so that you can find the sum of these sequences and series. Okay, so then here again, C represents some constant, and we are looking for the sum of the terms from the first term to the nth term. Okay, so the formula defines the summation of a sequence that is just a constant. Shortcut here is to take the value of n. Right, so again, n is the last term that we're going to take the sum of, and you multiply it by the value of c. Here we move on to this summation. So again, we're going to take the sum of a sequence which is created by changing our value of k. So again, we're going from the first term to the nth term. Okay, so for this particular summation, the formula is you're going to take the value of n multiplied by n plus 1 and divide it by 2. This will get you the sum of that particular sequence. Here we're taking a summation of a sequence that is described by k squared, and we want to go from the first term to the nth term. Okay, so the formula for this one is n times n plus 1 times 2n plus 1, all divided by 6. Here's one where it's k cubed. The sequence is described by k cubed. We want to take the sum of the first term all the way up to the nth term. So here's the formula for that one. Find that sum. Now this is going to be the alternative to actually listing out every single term. Okay, you want to be able to use these formulas, because as we know, formulas help you get answers much quicker. Okay, so I'm going to show you with these last two examples here how to use the formulas and the properties above. Okay, so for this one we want to find the summation of the sequence described by this expression, 3k minus 7, and we want to add from the first term to the 26th term. Okay, so what we want to do here is we want to look at the expression here that represents the sequence and try to break it up and see where we can use the properties. So one of the first things you're going to notice is the subtraction. Okay, so based off of this property, we're taking the subtraction up to the sum of the difference between two sequences. We can rewrite it as a subtraction of two separate summations. Okay, so that's what we're going to do with this one. And also we want to notice that if we break down 3k as a summation, well, let's go ahead and break it down first. So we'll do the first split. So it's going to be the summation of 3k minus the summation of that constant of 7. Okay, so again, I left out the notation for the 1 through 26, right, because I just want to be able to show you the properties, and then we'll go ahead and sub these back in. Alright, so we've got the summation of 3k minus the summation of 7. Alright, so now here I want to break down this 3 times k. This 3 times k, we want to break it up using this property, summation of a constant times some sequence. Alright, so we're going to pull out that constant and multiply it by the summation of just the sequence. so break this up as 3 times the summation of k minus the summation of 7. Okay, so here I'm showing you how we can use the properties from the notes above. Alright, so now we're going to use these formulas to help us find these individual sums. Right? These are two sums which we are going to subtract. Alright, so let me put in those numbers again. So we got k in the first term to the 26th term. And here we got from the first term to the 26th term. Alright, so this one right here, we are going to use this formula right here, the summation of a sequence that's described by this expression k. Alright, so here I'm going to plug in, remember I'm going from 1 to 26 here, so I'm going to plug 26 in for n. So it's going to be 26 times 26 plus 1, all divided by 2. So that is coming from this summation. And then, let me not forget, I'm going to multiply that all by 3. Then I'm going to subtract. So here we're taking a summation of a constant. So again, the summation of a constant, you see up here, is just n times that constant. So n is 26. It's going to be 26 times that constant. Okay, so we plug that all into our calculator. All right, to find these individual products, or just type it all at once. And when you do that, you should get 871 for an answer. Okay, so again, what we did was we took this expression and used the various properties to break it up. And using these various properties to rewrite it to the point where we can use a formula to find the sum. Alright, got one more example here. So here we got k cubed. Okay, so that one is going to be pretty straightforward. Right? But the difference here, the reason why we can't just use this formula, right? Because again, this formula, it goes with the summation, goes from a k value of 1 from the first term to the nth term. This one, we are starting with the 4th term and then going to the 16th term. Okay, so we're not starting at 1. So because we're not starting at 1, we can't just go to this formula to find the sum. So what we're going to need to do first is to use the property, this property, where we are going from some value, starting value, something other than 1. Okay, so I'm going to break up, I want to be able to break up that initial term value into a j value plus 1. Okay, so since I'm going to 4, so what I want to do first is I want to rewrite that as a summation from a k value of 3 plus 1 to 16 k cubed. Right? So again, I want to rewrite this initial value of 4 as a sum of some number in 1, and that number, of course, needs to be 3. Okay. So because my initial term doesn't start at 1, right? I want to be able to rewrite it like this. Okay, so now that's going to allow me again now to use this particular property. Alright, so maybe I'll have that off to the side here. So you can see how I'm using that property. Oops, there we go. Zooming in. Alright, so using this formula, I'm going to rewrite this summation as the sum of k equals 1 to 16 for k cubed minus the sum from the first term to that j variable value. So for the first one, let me finish this off. Right, so the first one, I'm going from 1 to 16. And for the second one, I'm going from 1 to 3. Right, again, that's where that 3 came from. Right, so I'm going to break up this 4 as 3 plus 1 so that I can use this property to write it as the difference of two summations. Okay, so now that we've broken up that way, now we can use back to here. Right, now we can use this formula, which again goes from the first term to the nth term. I got both of these summations for the k cubed sequence from 1, starting at 1 to some nth term. All right, so again, all I'm now using is this formula. So I'll put my n value here is 16, so it's going to be 16 squared times 16 plus 1 squared all over 4. I'm just plugging using this formula minus. Now here for this k cubed sequence summation, my n value is 3. So I'm going to plug 3 in for n. Into the formula. Okay, plug that all in my calculator. And I get a sum value of 18,460. Alright, so then the goal here with these summations is to first be able to use a property, alright, to be able to break up your summation into, alright, a combination of summations. And then from there, alright, you want to see if you can use a formula, alright, apply a formula to actually find the sum. Okay. Alright, so that's it for today. Hope you guys have a great day, and I'll see you tomorrow.